Okay, so let's discuss the last chapter or the last topic before midterms. And usually kaning 5 topics nga akong i-discuss or katong topics nga akong i-discuss pagsugod sa online class is mo to siya ang coverage Geotech 1 nga course. So katong 411C nga course code before. Now sa inyo is murag i-compress siya because after midterms it will be tackling topics on Geotech 2. So kato na mga application ng mga topics. Okay? So in this chapter we'll be talking about the behavior of the water in your soil specimen, and what we'll be looking into the particular parameter is your hydraulic conductivity. And I think this one is also being discussed in your fluid mechanics, if I'm not mistaken. But ang Bernoulli's equation is usually introduced in fluids 2 because fluids 1 is more on the basic na mga topics like getting the specific gravity, getting the different pressures per point beneath the water. Yeah, ang kaning Bernoulli's equation is it deals with the velocity head, the pressure head, and the different na mga parameters na kailangan nyo i-solve. So, una siya, you need the basic stuff first before you go to the Bernoulli's equation. Okay, so nevertheless, I'll be discussing roughly the contents of the hydro part, but for the deeper and more strenuous na pag-discuss sa topic is I think si Sir Fornis na siguro na or si Sir Alex, or if ever si Ma'am Kat or si Ma'am Jonah ninyo. Okay, so let's begin. Oops. Okay, so usually if you look at your soil in the microscopic view, so of course the murag bright colored part is your solid particles, yung mga yellow nga part, yung mga yellow na mga solids. And of course, since most of your solid particles are not the same shape as the others, so muna siya if you compress it together or make mo kanang compaction technique sa inyong specimen, so we can say that there are still voids present in your specimen, diba? And in these voids, dire mo agi ang inyong mga air and water. Now, in the earlier topics, we considered your water as in static condition, meaning wala pa yung movement. But in this topic is we will be dealing with the water voids with a certain movement na. So it could be horizontal movement or a vertical movement, because in your fluid mechanics, your water will move in the X, Y, and Z axis. But sa ato ang kuan lang, sa ato ang simpleng kanang kuan, simple nga pag-understand sa kaning topic is we'll be dealing with the movement of soil in the two-dimensional aspect lang, X and Y axis only. Okay. So there are macro pore flows, meaning na the flow of water is kaning dako siyang avoid ang iyang movement. And we also have mesopore flow, which in this manner, the water moves in the smaller void spaces. So muna siya nadje. So usually the geotech and the hydraulics nga mga subjects kay interrelated siya since water is also present in your soil. So labi na if you're going to deal with the hydrology nga topic atong hydrologic cycle. So di ba murag ini ka after sa precipitation, So ma-infiltrate ang water sa inyong soil, di ba? Musip then padung balik sa ocean. So muna siyang movement sa water sa inyong soil specimen. Okay, so the study of the flow of water through porous media is important in soil mechanics because estimating the quantity of groundwater seepage under various hydraulic conditions is very important since most site conditions will vary from place to place. So for example, katong nagtrabaho pa ako sa construction site, so among problem sa site is murag bahaon mi kanang nag-excavate pa mi sa kanang sa basement gani sa katong hotel. So among problem to sa site is magsige mig baha since because the water table is near the ground surface. Muna pagkaot pa lang namo daan a few meters from the natural grade line, okay, nagbaha na mo site na. And of course, if you have that particular kind of condition in your site, murag you need appropriate measures pod or a different approach in establishing your foundation layout. So it could be mat foundation para murag barko ang inyong building, di ba? Murag nakalatag siya sa tubig ana. So para siya kanang kuan, o siya galutaw sa kanang sa water ba. Of course you'll be applying deep foundation kay para maka establish siya sa iyang foundation sa bedrock. So muna siya mga usually na mga problems. So nasa mga sites nga ang quantity of underground seepage is very small kay ang natural grade line is very far from the surface. Like for example, in the University of San Carlos, the water table is 150 meters from the surface. So murag safe ra kayo, di ba? Usually ang atong mga foundation is usually, let's say for a high-rise building, so mga 20 meters mga 20 meters, mga 50 meters ang pag-establish sa foundation. So okay ra siya. And labi na that our soil type in the university is limestone, which is a very durable rock. So pwede po siya makuha, di ba? Pwede po siya ma-contribute dito sa Dolomite sa Manila Bay, di ba? Joke lang. Basta marag same na siya og kanang kuan. Usually the soil type in Cebu is kanang all throughout Cebu is the same. Murag more on limestone siya. But sa Balaban area is more of clay siya. Okay, so muna siya investigating problems involving the pumping of water for underground construction. So not only kanang construction for your foundation, but also for mining purposes. So for example, katong dito sa south, di ba, kana mga mining na mga companies. So if they kanang makasukat sila og kanang water table, di ba? So murag kailangan buhaton is they need to investigate first the level of the water muna na yung mga testing well or observation well. And after determining that particular level of water kanang sa mga deep well, di ba? So tas sa time nga ila nang ma-engineer their way into the particular source sa ilang kailangan nila i-mine. So murag problematic jud ang water sa construction. So aside from pumping water, so there are also other methods wherein we don't have to pump the water out, but we have to retain them. So examples of these are the earth dams and the earth retaining structures maka-retain sa water. So kanang sa inyo ang fluid mechanics, kanang mga dams ana. So mo pa na siya ang mga examples of this particular application. So aside instead of pumping the water out or eliminating the water, so we can also store them, di ba? But para sa ma-store siya, so we need an appropriate structure for it to, para ma-minimize ang iyang seepage, di ba? So na-seepage gamay, so because musipa na siya sa side sa inyong structure and underneath the structure, but it's very minimal compared sa walay structure jud at all. So examples of these are kanang sa Buisan Dam, nya kanang mga dam pa diya nga wala o kaila. So marag ang kuan na ang sweeto ana kay ang taga MCWD or katang mga expert of water. Okay, so let's go to the Bernoulli's equation. Okay, so usually when we discuss this one in the fluid mechanics, is muna siya ang pag-determine sa total head at one point. Okay, so the total head or the total calculation of the head, pressure head, di ba? Akan ng kuan? Tawagan na head loss or head added, ana, is the sum of the pressure head. So, ako ikaw na. So, kani siya is the pressure head, kaning first term. Plus the second term, which is the velocity head given by this term. And lastly, the elevation head or the Z. Ano siya? Elevation. So usually the elevation is just a number in which where you are referring your datum is. For example, na may datum dire ana, then muna siya inyong particular point is muna siya inyong Z ana. Yeah, plus the pressure head ana, then plus the velocity head ana. So bali mo na siya ang gawas sa inyong kuan. Now, again, I'm not really an expert on this topic because it's more thoroughly discussed in fluid mechanics. Bali ang kuan is ang basic stuff lang ang atong i-understand diri sa kaning equation. Okay? So if applied to the flow of water through a porous soil medium, so the equation simplifies to the pressure head plus the elevation head. Now, ano nawala man ang kuan? So why the velocity head disappeared? So ang inyong velocity head dire is nawala, di ba? So nawala man siya because again, if you read the statement, if applied to the flow of water through a porous soil medium, so again, if you're going to go back to the previous slide atong figure, so we have the macropore flow and the mesopore flow. So those particular flows are very minimal. Meaning ana, ang mga value sa inyong velocity is nana sa mga 0.00000 something ana. Yeah, when in case marag super negligible na kay siya, di ba? Even if you square it, di ba? Kung if you look at the numerator, you have to square the velocity and imagine that you have to square 0.000 something. Yeah, i-divide pa dyan yung 2, yeah, i-divide pa dyan ninyo yung gravity. So meaning nga na mo samot siya o kagamay, di ba? Maimo siyang 0.00000 something pwede siya maayo. Yeah, pwede siya ma-neglect lang since it's a very, very, very small number. So muna if we're going to find the head in the flow of water sa inyong soil, so we can just use this simplified formula. Now again, we're not going to use this formula in our problem solving, but at least we know the concept behind the Bernoulli equation in the flow of water through a soil medium. Okay. So questions so far? So wala ra? So let's see. Okay, wala ra. Okay, so usually is muna siya ang dagway sa inyong flow sa inyong Bernoulli's equation. Now the Bernoulli's equation will be coming from 2 observation wells or from 2 observation points. Now for example, muna siya inyong soil specimen. Kani siya. And again, your datum will be determined on a particular distance from your soil. Ana. For example, sa katong mean sea level pa rin ang iyang datum, ana, or you set your datum to 0. Ana. So muna siya yung mga z ng mga variables. Kani siya. Z variables up to the particular depth of your observation well. Now, kaninyong A and B, kani siya A and B, these are your observation wells. So again, ang gamit sa observation well is for you to determine the level of water in that particular point. Observation well. Or let's say pumping well ana. So kana mga deep wells sa ilang balay. So aside deep wells siya, so you can also use it as an observation well to determine the level of water. So mo to siya ang height sa inyong kuan. Sa inyong water table. Okay? So again, your datum. So let's say you set your datum at this particular point, and then from this datum going to the bottom part of your observation well is your elevation head. Ano siya? Elevation head. Now, next is the pressure head. Now, I think you have discussed this one in your fluid mechanics. So from the surface of the water going to the particular point beneath the water level is your pressure, di ba? Katong inyong gamma H. So muna siya. So from the water surface going to that particular bottom point A is muna siya inyong pressure head. So same goes for the other observation well also. This one is also your pressure head. Now the difference in the elevation or the difference of the total heads between the 2 points is what you call as the head difference. So if it's negative, I mean if it's kanang kuan, kanang okay, if negative siya, so meaning na head loss na. If positive po siya, so head added. So to explain it better, ang kanang head loss is mas better siya because if you let the water flow through the upper point going to the lower point, so you don't have to use energy as much as kanang going upwards kay you let gravity do its work man, di ba? From or letting the flow of water from point A to point B using gravity. Now, for example, diya sa inyong balay, so for sure sa inyong mga household, namo may mga water tank diya sa inyong balay, di ba? Yan yung water tank is usually murag the same level as your roof, ana. Or let's say higher, di ba? If let's say you have a 3-story house. So usually our pipes from the main line is nana siya sa underneath sa ato ang mga yuta, di ba? Now kana siya is you need a particular pressure for it to go to your water tank. Now muna siya ang one example of the head added. So usually if the pressure of water is this much, nya di siya kasaka sa inyong mga tangke, so that's the time that you will need to add a pump. Okay, para murag mo-shoot ang inyong water sa inyong mga tanks. So muna siya mga one way of kuansad anang transporting water from the lower point going to the higher point. Muna siya head added. Musa na siya ang gamit sad sa pag-compute sa tong total head or the head difference. Basahin nyo, discuss na ninyo more sa inyong fluid mechanics. Okay? So usually we measure our soil, ang length sa soil parallel to the direction of the flow. So muna siya tong L because the direction of the flow is this way. Diba? Dapat parallel siya sa direction sa flow. So again, ako isuot na so the length should be parallel to the direction of the flow. So questions so far? So wala pa? So let's see if may questions. Alt H. Oh, okay. Wala. Okay, so let's go to the next slide. Okay, so the loss of head between 2 points. So again, this statement can also be the head added or the added head between points A and B, because sa picture ganina is we can just see that it's a head loss because point A is higher than point B. So muna ang gikuan diri nga statement is head loss or loss of head between points A and B. Okay, now if we're going to look at the computation, so the total head at point A is given by this equation. So laylayan sila nga mga parameters, di ba? So pressure at A and then divided by gamma water plus the elevation head at A. Then B also has a different quantity as well. Okay, so head loss delta H can be expressed in a non-dimensional form as I equals delta H all over L, wherein I, so sorry for this one, so it should be small I. So I is the hydraulic gradient and L is the flow of water from A to B. Again, as what I have mentioned in the previous slide, L should be parallel to the direction of the flow. So H again is the head loss or the head added or the difference of head between 2 points. Now, if this particular parameter is not given in the problem, so what you need to do is, of course, you have to solve it using these equations. Ano siya dire? So determine the elevation head, determine the pressure head, to determine the difference of heads in points A and B or between 2 points. So simple pa, di ba? Simple pa? Or lisod-lisod na? Okay, so let's go on to the next slide. So I think this one will be discussed thoroughly in your fluid mechanics. So we have the laminar flow zone, the transition zone, and the turbulent flow zone. So if you're going to evaluate or analyze this particular graph, so the higher the hydraulic conductivity, meaning ana, ang inyong velocity is dako sa, di ba? So kung tanawin ninyo, di ba? So in this particular region, so we can say that our flow is laminar, or let's say ang iyahang sama na siya pag-describe sa, excuse me, sa marag sama na siya pagkuhan sa fluid mechanics. Now, na-experiment sa fluid mechanics wherein you have to kanang determine the flow of the water, whether it's laminar or turbulent, using a particular dye. Kanang marag kanang tina ba? Tina. Or let's say coloring, ana, if di pa dyan masabtan. Okay, so murag ang buhaton na is ikuan lang siya. So you have to set the velocity at this particular point, and then inyong focus ka na sa ang kanang flow sa water na sad, and you will determine the type of flow of water using the Reynolds number. Na murag nakalimutan ko sa formula to kay murag kuan sad kanang dili sa kay ko kanang water before kay baka kanang ibaw na mo kay atong teacher sa lisod sad na. Sa inyo iba si sir ha kay kuan tinod lisod jud si sir for next jud kay kanang kuan siya jud ang among water teacher all throughout my college life ana. Di yung ka-relate sa water kay kuan kay lisod siya. Yan masayon pa ang geo and structural para nako. So man bago ko malipay sa water kay akong kuha trace ra na trace. Kay basic ra kay ako masabtan sa water niya. Di ko ka visualize gani. Kay para nako ano na may water sa civil engineering ana. Ano na may water kay nya akong gi-think ra jud sa civil engineering is mga building ana building. Wala na open akong utok sa other kuan ba aspects sa civil engineering. Okay? So muna siya, so you have different flows or types of flow sa inyong mga soil specimen. So again, the higher the velocity, meaning the higher the hydraulic gradient. Because of course, the velocity head will create also a great pressure, di ba? So dili siya totally great pressure because again, the velocity is very minimal sa inyong soil medium, but significant enough for it to rise. Okay, so in the graph again, so we can say that your velocity is directly proportional to your hydraulic gradient. Okay, so of course, if again the flow of water will be different for different soil types. So for example, if you have a sandy soil, so of course you can say that the flow of water is laminar. So for example, para sa dagat, di ba? Ini ka hapak sa water sa shore. So dali ra po siya mohubas, di ba? Na. Then for clay soil, so it could be a different type of flow also. So it could be laminar but kanang closer to zero na iyang flow since clay soil have small void spaces, ba? Now of course, if you have stones, gravels, and very coarse sands, so we can say that the flow of water will be turbulent, but the equation may not be valid since, of course, it's difficult for you to verify your equation, di ba? If you have such a condition, kay murag kuan kay ang kuan ba ang scenario murag tawag na impossible sa siya may tabo sad. Diba? Murag ano kailangan mo flow ang water through gravelly to cobbles ana mga dagko nga stone ana. Okay, so let's go to Darcy's law. And in Darcy's law is we'll be looking into the discharge velocity of water through saturated soils. Now, for example, in this particular figure, so let's say this one is your soil specimen and it's being sandwiched between two porous stone. Porous stone siya, porous stone. So ang kamit sa porous stone is kanang for water to flow through that particular specimen ana. Muna siyang gamit sa porous stone. Okay? Now if you're going to look at the figure, so the flow rate is in this direction and it's being represented as a small q. So small q siya. So usually is muna siya ang discharge sa inyong fluid mechanics. Now in your fluid mechanics, your discharge is usually represented as big Q. A big Q ang pag-represent sa discharge or the flow rate. So usually the flow rate is usually in, so atong i-erase ang Q lang ha kay para di mo maglibog. So again, ang katong big Q is usually the parameter in your fluid mechanics. So small q is the discharge in soil mechanics. And it's usually volume over time ang iyahang kuan, ang iyahang pag-represent sa iyang formula. Or let's say pwede po siya kuan, basta ang labas sa iyang units is let's say cubic meter per second ana, di ba? Mga na siya ng mga, or let's say cubic meter per hour or cm cube per second ana. So depende na siya sa pag-present sa inyong equation. Or what particular unit is the problem, ang problem kay gipangayo sa problem sa inyong kuan sa discharge. So lain-lain na siya pagka-present basta as long as it's volume over time, di ba? So puro volume ang numerator, then the denominator is puro sa time. Okay, so if you look at the second figure on the right, upper right, so you can see that the area of the soil specimen is this one, and it's being represented as A. So if you're going to look at the first figure and the second figure, so we can say that the area is always perpendicular to the direction of the flow. So perpendicular na siya. So sakto, di ba? Perpendicular to the, so ako lang i-shortcut na perpendicular to the flow. So ganiya, so again, if you're going to look at the two different figures, so kanina I stated that the length is parallel to the direction of the flow, which is true also in this case. So if you're going to look at the length, ano siya, length, so it's parallel in the direction of the flow. It's horizontal also. Ang area, so muna siyang area, it's perpendicular to the direction of the flow. So drawing lang diri sa right side balik. Okay? Now on the lower right figure, so we can say that if we try to rearrange our soil sample according to density, so of course the solid particles will be settling down the bottom of your kaning container. Ano siya, di ba? And this particular area is the area of the solid. Okay? And this particular void space, di ba? So let's say we can compress perfectly our soil solids. So meaning we can group all together the solids at the bottom part. So kani siya for the sake of illustration lang So we cannot really crush the, I mean we can crush the soil sample into very small pieces, but in actual practice is of course we cannot do such thing kay kuansad. Gusto po siya achieve, di ba? So for example, you're going to crush 1 hectare of land para lang ma-divide niyo ang area sa solid and area sa voids, di ba? So murag hago-hago po siya nga trabaho, di ba? And the white portion is the area of the void spaces and represented as A sub V. Okay? So unsa may purpose kano ato ni siyang ikuan. So the purpose of which is in the next slide is will be determining the discharge velocity. So according to Darcy, so the discharge velocity of water through saturated soils is V equals Ki. So discharge velocity is the V. So that's the quantity of water flowing in the unit of time through a unit cross-sectional area of soil. And K is the hydraulic conductivity. So again, this will be the coefficient of permeability that we have to determine in your soil specimen. So the hydraulic conductivity per soil type will vary from different soils. And we all know that I is the hydraulic gradient, di ba? Okay? So kani siya is murag ako ra na siyang gikuan sad. So na po yung shortcut ani if makalimot mo aning simple nga formula. Ana. So murag amot lang if offensive ba ni siya sa kuan, but ang story ani is that if you're trying to recall Darcy's law nga formula, di ba? So all you have to do is imagine that Darcy is kay bayot si Darcy, di ba? Na bayot. Di ba? Bayot si Darcy. Ba letter V, di ba? Yan sa may button sa bayot ug Mulakaw, di ba mo KI, di ba? Mo KI. Na ang bayot ni KI. Na, so at least namo na nasa mo lain corny na formula, di ba? So ana na siya pag-memorize, dali na kay, di ba? So okay ra, di ba? So maka-remember na mo nga mo na siyang formula ni Darcy na sa mga mo nga si Darcy bayot na bayot. So no offense sa mga ko na kay kani ako is for memorization na ni siya. No hate sa mga kuan LGBT community. Okay, so let's go to the next. So earlier I showed you the three figures katong naay areas of void space. Now mo na siya ang katong kuan particular formula. So this charge can also be solved using formula. This formula. So discharge velocity. So we all know that this one is discharge velocity coming from the previous slide, coming from Darcy's law, di ba? And A is the area of your total specimen or of your soil specimen, di ba? Total area na siya. Apil ang void space. Okay? Now, we can also use the other formula, which is A sub V, ba? Meaning we have to determine the area of the void space alone. Atong third figure sa last two slides. And Vs is your seepage velocity. So seepage velocity. So meaning if V sub S, yeah, so you're only considering the flow of water through an empty space. Meaning ana walay mga obstruction. So if may obstruction, is kanin yung gamiton. If wala, kay kanin yung gamiton sad. So line-line siya na mga line-line siya pag-present, di ba? So other formula for your Vs. So your seepage velocity is V over N. Now we all know that your N is the porosity. So coming from the previous topics. So I think kanisha is a way of memorizing the formula or nakalimot lang siguro ko. Kaya it doesn't ring a bell sa basta himo-himo lang ninyo kaya para at least maka-discover sa mo sa inyong mga talents sad. So again, your discharge or the flow rate is equal to V times A velocity times the area. Or you can also use the void space area times the seepage velocity. It could either be the two formulas, but usually what we're going to use is this first term, kaning discharge velocity times the total area. So we only use the other formula if you are looking for the seepage velocity or the area of your void space. So mura na siya gamit sa kaning right formula. So questions so far? Wala ra? So what are questions? Okay, so let's move on. Okay, so as what I have discussed earlier, so the hydraulic conductivity will depend on several factors. So fluid viscosity is the first one. So not all times nga ang mo-flow sa inyong soil specimen is water, di ba? Because we have different kanang mga disposed na mga fluids sa ato ang areas. So it could be sludge na garbage sludge or kanang mga oil, mga chemicals, di ba? So daghan kayo og mga different types of fluids nga ma-flow kanang mapunta sa inyong soil. So that's why the number one factor that affects the hydraulic conductivity of your soils is your fluid viscosity. So you have different viscosity per fluid type. So water, oil, sa pa na siya diya ng mga fluids. Okay, now kaning kaninyong next three are interrelated. So pore size, grain size distribution, and void ratio. So if your pore size is big, so of course the grain size will also be different. And if your grain size is also big also, di ba? So it produces a big void ratio. So marag interrelated na siya tulo. So of course, if your pore or if your soil specimen has very minute particles, so we can say that the grain size distribution is more on the fine sides, not on the coarser sides. Yeah, of course, the void ratio will also be very minimal. So if gamay ang void ratio, if the void ratio is very small, so it also affects the hydraulic conductivity of your specimen since the flow of water will be slow compared to the flow of water if you have bigger voids or bigger void spaces. Diba? Mas dali ang flow sa water if you have bigger voids. Okay. So next is the roughness of mineral particles. And of course, you have different values of, you have different minerals that are present in your different soils, diba? So for example, naamoy mga kanang mga dolomite, diorite, so mga different minerals per soil ang present. So there are also minerals that are reactive to water or certain fluids. So kana ma-create siya mga chemical processes and it also hinders or it also affects the hydraulic conductivity of your specimen. And lastly is your degree of saturation. So of course, it also affects the hydraulic conductivity. Okay, for example, if your soil is already saturated, diba? So ining flow ana sa mga empty void space, yeah, let's say the water is just on static condition. So na siya kanang factor sad na maka-affect sa flow sa water. Kay it could also mean that kailangan pa siya og certain amount of pressure for that particular amount of water nga naa sa static condition to move, di ba? So marag daghan siya og kuan sad degree of saturation. So maka-imagine mo na. Okay, so you can also solve the hydraulic conductivity of your soil if you have the absolute permeability and if you also have the viscosity of water. So usually this particular formula is hindi kayo siya magawas sa board exam, but ako lang ipakita kay base niya. Base niya, di ba? Okay, so let's head to the laboratory experiment in determining the hydraulic conductivity of your specimen. So there are two laboratory tests to determine the hydraulic conductivity of your soil. And these are the constant head permeability and the falling head permeability test. So the constant head will be used for coarse grained soils and the, the latter will be used for fine grained soils. So to compare the two different tests, so mas dali mahuman ang constant head since you have bigger void space. Then ang falling head is usually 1 to 3 days since you are testing it in fine grains or smaller void ratio na specimens. So muna ang flow sa water is murag very small jud kayo. Muna maabtan pa siya og mga greater than 1 day para namoy kanang dako nga reading nga makita jud sa kaning experiment. So mura na siya inig ang inyong pag-determine sa let's say sama na siya pag na sa falling head. Murag if sa constant head nagbutang mo og kanang apple sa beginning sa stream, so maabot na siya dito sa tumo sa stream mga 5 minutes ana. Inig sa falling head, murag if ang butang mo og kanang orange or apple sa kanang beginning sa stream, pwede pa ninyo biyaan og kanang one isa ka adlaw niya. Ibalik ninyo na siya tunga-tunga na murag nana pa ang yang na cover nga distance ba. Dili kay siya dako nga kanang coverage. Okay? So constant head is just simple. So you just let the water flow in the specimen and what you need to achieve is a constant flow rate in the outflow. So you need to achieve a constant flow rate in the outlet. Now, of course, for you to determine the discharge and for you to determine the hydraulic conductivity is, of course, you just have to collect a water for a certain amount of time. Diba? Volume over time is discharge. So this will be the diagram for your constant head. Now, ang gamit niya is again, you just have to continually let an inflow of water through your soil specimen. Yeah, dapat ang inyong outflow should also be constantly flowing outwards, di ba? Balik constant ang iyang outflow. So constant inflow of water and then constant outflow of water. Now now at the beginning of the experiment, so of course since the water is still traveling through your specimen, so mangita pa na siya mga macro pore flow and mesopore flow. Now once the flow has been established, so you can say that your setup is in constant condition because the outflow will be constantly murag kanang di na siya kanang if mangiipa mo ba murag let's say you're urinating, so ang outflow ninyo is continuously on that particular pressure, di ba? So di siya magputol-putol na. So continuously pouring outward siya. Na, di ba? So mas dali masabtan, di ba? If kanang kuan. So if you have a constant outflow, so that's the time that you have to collect a certain amount of water using your graduated cylinder or any kanang kuan volume nga mga flask, let's say a beaker or any apparatus nga mo measure og volume. Now, of course, in the laboratory experiment, so you can para for you to mas easy siya ikuan, so you can collect 500 ml, then you stop the time, or you you run the time at 5 seconds, then kuno sa 5 seconds, whatever is the volume collected is muna siya inyong volume sa dana. So you can either fix the volume or fix the time in determining um, the discharge or the flow rate. So if you're going to look at the different parameters presented in the diagram, so notice that this one is L, di ba? So ano vertical man L. So again, as what I have mentioned earlier, your length should be parallel to the direction of the flow. Now, since the direction of the flow is downwards, so dapat ang inyong measurement sa inyong soil is also in this particular axis, which is the y-axis. So muna siya ang ato ang L. Okay? Now again, your H is from the inflow or from the water surface going towards the particular bottom point of your soil specimen, which is this one, H. Muna siya inyong H. So if you're going to calculate the discharge, I mean the hydraulic conductivity, since the point of this test is to determine the hydraulic conductivity. So your discharge is Q is equal to the discharge velocity times the area, diba? And then again, according to Darcy, ang value ni KI, diba? So KI times A. Diba? And then after is your I is your hydraulic conductivity, diba? So again, I is H over L, diba? H all over L times A. Now again, our A should be perpendicular to the direction of the flow, diba? So muna siya dapat ang A, diba? So perpendicular to the direction of the flow. So muna siya inyong cross-sectional area sa inyong specimen. Now we have A, we have H, we have L, and we also have Q. So what is left in our equation is the hydraulic conductivity. So ana siya ang pag-perform sa experiment. Dali ra kayo. And you just have to look for sandy na mga soils. You're going to use this experiment for coarse materials. Okay. So questions so far? Wala ra? Okay, so let's go on to the next. So muna siya ang akong gipakuan. Ang ipakita nga formula ganina. So let's try to break it down again, the formula. So kaning Q, if you read the slide, that's the total volume of water. So medyo libog lang siya, di ba? Pwede mata siya capital V. But the book is using capital Q as the total volume of water. Now again, if you're going to look at the first kaning kuan first part of the formula. So gikan gyapon na siya dire na sa Q equals VA. Nya ayang gihimo is iya lang kanang in terms of volume over time ang inyong discharge. Muna may mo siyang Q over T equals V times A. Yan, i-multiply sa kuan. So may mo siyang Q equals AVT, di ba? Na i-multiply sa T sa other side is may mo siyang Q equals AVT. Na. Okay? Now, further simplifying is we're going to replace the V using Darcy's law. Na. So, muna siyang bagong formula. Yeah, further simplifying the formula is you have K equals A na H over L times T na. So muna siya ang kuan dyan. Ano pa dahil K dahil. Okay. Let's try ato lang tarong suwata para kuan. Okay, so A times K H over L times T. Or in other terms, that's QL AKHT. Na. Okay? So usually, if you're going to memorize the formula, so nasa tayo another memorization technique. So what I usually do in this particular formula is ako lang siyang balihon pagkasuwat. Ako lang siyang i-rewrite balik. Ako lang inana. Ako lang unahon si AKIT. Then ang kuan is AVT sa dang last na. Ako lang balihon. Okay? So usually para memorize niyo ang formula is that may mo siyang kuan anang sa So usually mahimo siyang ang iyang pag-uwi sa memorize sa formula is if na may kabit, di ba? Kaya sakit mo na siya, di ba? Sakit if may kabit. So masakit kapag may kabit na. Masakit kapag may kabit na. Kabit. Sa mga witty kayo mga kuan, di ba? Mga witty kayo mga way of memorizing the formula. Masakit kapag may kabit. Yeah, of course. Parang muhaom sa ng Q, di ba? Pero parang nila siya muhaom sa first word. Masakit kakit kapag may kabit na. So kaning masakit kapag may kabit na formula is dili pa na siya mao ang simplified version. But ang simplified version is kaning QL, di ba? Na usually kaning other formula is ako na siyang i-rearrange na ako lang i-kuha na wait sa ako lang i-erase kayo. So ako lang na siyang i-rearrange. So kaning right hand side kaning AKHT ako lang siyang equals QL ana. So usually ang sumpay ani masakit kapag may kabit, di ba? Usually ang sumpay ani is kaning kahit, di ba? Kahit kahit may mga uyab na, may mga asawa, may mga kuan is inig pangabit. So asa man lang kanang kuan, asa lang kanang dadon. Dadon sa kana di ba? So alarms na di ba? Alarms na asa padong. So basin masuko si kuan diri si Parley ba to? Basta kuan na siya, wala na siya kanang basta before man ako na student kay bali na siya niya formula jud. Ako na siya ang gipresentaan sa ako ang 6 years of teaching. Mga sweet to kayo, 350 ra ko no. Na. Basi nang adto na mo dito na, basi nang adto na mo dito. Basta og mga adto mo dito kay pagdalan siya mo kuan. Pagdaan na mo og kanang basta kay bawo na mo sila doon. Okay, so muna siyang storya. So at least namoy ka ng mga corny, mga witty na mga way of memorizing the formula. Na, if kanang disan mo kana sa kaning style, so you can again, you can make your own style of memorizing the formula. So usually is muna siya ang gi-present sa mga before sa sa review na mo. Ya, muna siya katong mga bago na mga mag-review ron sa Mega kay may mga hot na mga review center is murag ilang pag-memorize sa mga formula sa geotech is kani jud ako ang method jud kay mas dali ko no. Murag ilang na po na incorporate from college daan kay masayo naman siya. Ang ilang problema na lang sa board exam is kato na lang mga structural na mga formula. Kay sa geotech kay na may mga corny nga formula nga dali ra kay ma-recall compared sa other subjects. At least makatabang ko gamay sa kuan pag-memorize sa formulas. And basin sad maka-create sad mo og inyong own method of memorizing the formulas in other subjects like sa fluid mechanics, di ba? Okay, so muna siya ang kuan, ang formula in the book. But again, I have simplified it as katong kahit may kavit, di ba? Papunta pa rin sa QL. Masakit kapag may kavit. Kahit may kavit, diba? Kahit may asawa, may boyfriend, may girlfriend, ay pupunta pa rin sa QL. Ana. So, ano mapunta man dito? Magpabugnaw kay, of course, aircon man, di ba? Kamo jud. So, may nag-chat diri unsa ko nang kuan? Og kanang sa Manila pa na siya nga kanang kuan advertisement nato yung murag advertising ad sa billboard sa to group study sa Sogo Hotel ana. Very sad. Okay, so next is your falling head test. So kato mga na fall ana pwede kayo lang test dire. Ito joke lang. So falling head test is muna siya ang for the fine-grained soils. So the same setup as your constant head, but since the flow of water is very slow, so what will happen is ang inyong difference in head will be calculated from time 1 to time 2. So ang atong pag-generate ani or pagsabot sa kaning experiment is that, for example, since the flow of water is very minimal, so let's say muna siya ang first elevation sa ato ang water, diba, sa inflow sa water. So meaning ana mag-create pa na siya og flow dili sa inyong specimen ya muga ato sa outflow. But again, it will take greater than, let's say, 24 hours for a certain reading to be achieved. So let's say muna siya inyong H1, ya, let's say nibalik mugma sa lab, and then muna siya inyong bago na level sa water head, H2. Diba muna siya inyong H2. Now of course, we cannot, sa katong previous experiment is we can immediately determine the head loss or the delta H because the water is continuously flowing, di ba? Dire is parang hinay kaya ang flow sa water. That's why you can determine a difference in head. Kani siya. H, di ba? Or you can just subtract this one, di ba? Muna siya inyong H, delta H. So again, this one is also the length of your specimen since the direction of the flow is parallel to the length. And this one is your area, the cross-sectional area, which is perpendicular to the flow of water. So may difference sa duha. Ang isa, paspas mo man, ang kaning kaduha is dugay na more than 1 day. Diba? So usually basta constant na dali ra mo dyan na, di ba? Dali ra mahuman na. If falling, na ma-fall ka, na dugay ka get over, di ba? Magmaoy pa. Na, mga hugot lines. So muna siya ang kaning experiment. So for the formula of the falling head is muna siya. The same formula will be used, but since the inflow of water is different, kay dili man siya directly applied sa inyong soil specimen unlike the constant head. So we'll be using a standpipe, meaning ana di ninyo ibutang inyong water katong ganina gani dire. Ba kani siya dire sa kanina ay DH nga variable. So muna siya ang standpipe since dili man automatically mahurot ang water. So we can just place the water there and you can observe a difference in reading, diba? From time 1 to time 2. Now for the derivation of this formula is the mo mind sa derivation since we're just interested in the formula. Okay, so muna siya ang formula sa falling head. Okay, so kaning K is equal to 2.303. So AL. So again, the small a is the area of the standpipe. Ano siya? L is the length of the specimen. A is the area of the soil specimen. T is the time. So let's say inyong i-read ang H1 and H2 at let's say 25 hours or 36 hours na mark. Diba? Then H1 and H2 is the reading, the initial head and the final head. Okay. Now, if you're going to memorize this formula, so I suggest that you use this one, kani siya, para you don't have to memorize the kaning coefficient, kaning 2.303. Yung basin dili niya mo ma-sure sad if unsaon siya pag memorize later on. Kaya daghan ba siya mga napay other formula nga 2.727 if you're going to use ln. Now kani siya para madali ang pag-memorize ani sa falling head. So ganina sa constant head is naamoy masakit kapag may kavit, di ba? So dire is nasa mo'y lain na story sad. Na sa falling head, so may tabo sa falling head is kuan siya. Na if na-fall na wag mga Tagalog, na, so rearranging the formula, di ba? Tagalog, di ba? Tagalog E. H1 over H2. So ang na-fall man kanya, it's because Tagalog E. Tagalog E. Corny kina, corny. So bahala na corny, basta at least makamemorize sa formula. Di ba? So muna siya. So other formulas presented in the book, so aside from log sub E, so you can represent this log sub E as ln, ln H1 over H2. Piniput takalin. Ba Tagalog Tagalog lang. Tagalog kanang murag Tagalog. Sige na mga sa akin, di ko kabawon sa nang siyang apart sa Manila kanang alae, ana, di ba? So muna siya sa kanang kuan. Tagalog Tagalog. So at least nasa mo yung other formula na sad in memorizing the formula. Okay, so far so good. So questions or no questions so far? So let's see the chat box. Okay, so wala pa, okay. So let's move to the next slide. So I think this one is an example, Asad. Okay, example. Okay, so in problems, let's say sa yung problem set later on, is mo hiskuchud always a problem whether you are performing a constant head or a falling head laboratory experiment. Usually, the data is already given. And yung button is, of course, you just have to look for what is asked in the problem. Okay, so constant head test, and then these are the data. So length, diameter of specimen, head difference, water collected, and void ratio. Now we have to look for the hydraulic conductivity, K in cm per minute. Then discharge velocity, cm per minute. Seepage velocity, cm per minute. So again, our discharge velocity is v, di ba? Seepage velocity is v sub s. So kaya, di ba? So again, constant head. So automatically, kato na lang dito sa kahit may uyab na or kahit minyo na ang kabit doon sa QL kaya para di masakpan. So K, di ba? We have to solve K. A, what A, but we have the diameter. Now, since diameter man siya, so automatically our area is circle, di ba? Kaya sa makita mo later on sa laboratory nga experiment nga ang kaning vessel sa inyong experiment kani siyang sulanan kaning permeameter. So tawagan niya sa lab is permeameter. So kaning permeameter is cylinder na siya. So again, since our area is perpendicular to the direction of the flow, so we can see that the area of the specimen is circular, di ba? So we can solve for the area. Ang H is already given, 460 mm. Time is also given, di ba? 2 minutes, di ba? 2 minutes. So Q is the volume again, di ba? So given 0.51 cm cube. And the length is also given 250 mm. So again, we can automatically solve this one using the formula. So K, again, our area is pi d squared over 4 since we are given the diameter. So again, since mm man siya and we have to get cm per minute, so what we need to do is to convert it. So 1 cm is 10 mm, di ba? Sakto? So this will be 6.4 cm, divided by 10. So pi d squared over 4 times the h, the head difference, and that's times 46, times 46. And then lastly is the time. So since it's in minutes, so times 2 ulit so. So Q is already in cm per cube, diba? cm, I mean cm cube na siya daan, diba? So that's 0.51. And then the length is 25 in cm. Now, so you can now solve for your K. So let's try to solve it first. Kung ikaw na. So relax lang magamay. Or if na ay makahatag sa answer kay mas maayo. 6.4 times 6.4. Oops. So ako lang ikaw na. So ako lang ikaw para di malangay. Oops. Now, so the K is 4.56 times 10 to the power of negative 5 cm per minute. So kung tanawin ninyo, super gamay ang movement sa water, di ba? Meaning ana, ang movement sa inyong water per minute is this much, 0.00004 cm, or let's say 0.0005 approximately cm per minute. So gamay kayo, di ba? Okay, so to solve for the discharge velocity, so you have to use the katong formula ni Darcy, di ba? So ang value ni KI, di ba? So naamoy K sa letter A. So what you have to do is to solve for the H over L. So 4.56 times 10 to the power of negative 5 times H over L, di ba? Because that's the hydraulic conductivity. So since cm per minute kaya po siya, again, yung H over L will not matter whether you plug in mm or cm because the units will just cancel out sa kaning term, di ba? Kay I is a non-dimensional unit. So meaning na kuan siya unitless. Okay, so H is 46 all over 25. So your V, so times 46 divided by 25. So ambot lang, sakto ba niya akong pag-calculate? So just verify it later on. Kanang kamukha mo na lang. Times 10 to the power of negative 5 cm per minute. Okay, so lastly is your seepage velocity. So asa man ako butang ha. So seepage velocity is V all over N, di ba? Now what I N? But we have the void ratio given. Now again, if you still remember the formula sa katong weight volume relationship na topic, so ang void ratio, di ba, in terms of N is iniwanan, di ba? Ine, diday, ine, 1 masiguro na, or iniwanan. Basta nakalimot ko, basta E equals N, basta ikuan lang, ine, wanan, iniwanan na yung formula. Okay, so, bali day. Hindi ni mo itong formula, bali day, sorry. So since we are looking for n di ay, so dapat iniwanan din siya nga formula. And yeah, iniwanan di ba? Na1 ay na1 na. Hasta ako galibog sa ko. So 0.46 all over 0.46 plus 1. That's your n. So let's try to solve it. So 0.46 divided by 1.46. So 0.46 divided by 1.46. So 0.32. So dire is naamoy 8.4 times 10 to the power of negative 5 divided by 0.32. So Vs is 8.4. Goy murag ato na ni kuan 0.000. So murag kuan na siya 2.62 mo siguro ni. Mag-feel lang ko din mo ako answer basta ikuan lang siya, i-verify lang siya later sa inyong kan kay akong gamit na calculator ako ra cellphone. Okay? So muna siya ang inyong kan. Example 5.1. So questions or clarifications. So murag ako maingon jud ani nga kuan is if naay formula maka-answer jud mo. Yung murag minimal ra kayo ang kuan ang analysis ka part. Mag dapat kibawra mo pahanay sa inyong mga kuan. Okay, so I think wala question. Okay, so let's move on to the next. Okay, so example 5.2. So still constant head. So constant head permeability test. And you're just given these data. So length, and then the specimen area, and then the K. So the head difference was slowly changed in steps to 800, 700, 600, 500, and 400 mm. So calculate the plot and plot the rate of flow Q through the specimen in cm cube per second against the head difference. So ang ipangay sa problem kay graph, so what you need to do is since you have different h mga parameters, diba? So starting from 800, so let's say muna siya yung h. Sayang lang dyan yung akong drawing nga kay murag mahal-mahal to sa itong graphic tablet. 800, 700, 600, 500, and then 400. So we need to determine Q, di ba? So KIA gapon ana. So natay little cheat during a formula na sa left side for us to be guided. So about nyo ana is since you have all the formulas, so kato pwede no ana kahit na pwede sa inyo usbo ng kuan ang story, di ba? So let's say daghan mo na atuan ng mga kuan ng mga kanang pabugnawan na area. Oh, ato inon kahit kuan sa QL pa rin ana, di ba? Kuan ba loyal loyal sa isa ka kuan. Na kay mas bugnaw dito ang aircon kumpara sa uban ana, di ba? So muna siya. So pwede rin yung shortcut na kahit equals QL, ano, di ba? So kamo na kanang bala sa story ana o kung saan ninyo pagkuha na. So na ni chatri swito ko nako, mas swito jud kay tiguang nagugo. So daghan na agian sa kinabuhi. Ya at least kanang kuan sad atong sa mga ihas, at least din na mo ihas, di ba? Among-among na dis. Okay, so nawa na sad nawa na nung ko. Sige, balik ta sa formula. So since namo may k, so k is given in the problem. Yeah, a is also given in the problem. Yeah, inyong age is different per trial. Ana. So you have 5 trials. So meaning kani siya nga parameter dire, kanya akong gi-extend dire sa left side is maglahi-lahi siya, di ba? Now inyong t is asa tong t dire. So wala, di ba? So calculate and plot the rate of flow Q for the specimen in cm cube per second against the head difference. Now since wala man tay t, but wasa tay kanang kuan, kaning Q. So atong button na is of course ato siyang kuan, di ba? Ato siyang i-manipulate ang formula. So may mo na siyang cut QL. Na, di ba? So akong i-divide ang H sa other side. I mean ang kuan day. Sa ang H, I mean ang T sa other side kaya para may mo siyang tibok Q. Kay mamanato ang gipangita, di ba? Na ka QL. Pa mangitag kaka sa QL. Okay? Uy, na akin. So again, naatay I mean K. So ako lang drawing balik ha. Nagubot na dyan yung kuhan. So naatay K, naatay H, I mean A. Again, ang H is different per trial. Okay, since we're going to plot the different head difference, 800 to 400. Yeah. Sa every new data sa H, maka-generate tag new data sa inyong Q. Then L is 300. So kamo na lay kuha na, kamo na lay calculate kaya magdagan-dagan na siya pag-calculate, di ba? Yeah, pwede na siya i-shift solve as kay pwede pa man pwede pa man mag shift solve karon. But I think in the board exam is you'll be using the katong bati nga formula. I mean bati nga calculator. Katong dili maka shift solve. Yeah, one line ra ang screen sa inyong calculator. Katong basta katong bati nga version. Kanang ining fraction ninyo kay bar gani, maginana ang kuan sa, so let's say 1/3, maana siya nga pagkuan sa calculator. Butaan na ba or ana kalimot ko sa dagway sa calculator ana. Sa maginana ang dagway sa fraction. O mag-square mo ana, ang square ana ba jud. Usa ka namati nga calculator. Dili pwede mo shift solve. So muna marag ma-test ang inyong algebra ining board exam. Okay, so let's go to the next. So marag 4 naman so muna siyang answer. And I think it's also available in the PDF PowerPoint na akong i-publish later. Okay, so muna siya. And then after determining the different flow rate or discharge per that particular head or head difference, okay, we have to plot it, diba, H against the flow rate. So muna siya. So we can tell that the higher the head difference, so meaning ana ang iyang flow rate is also big. Baka directly proportional man, di ba? So again, according to Darcy, so the discharge velocity is directly proportional sa inyong hydraulic gradient, di ba? So V is directly proportional to I. So muna siya ang inyong kanang kuan. So maka-verify ni nga example. Okay, so permeable soil is underlain by an impervious layer as shown in the figure. So with K equals 4.8 times 10 to the power of -3 cm per second for the permeable layer. So calculate the rate of seepage. So murag na kuan na seepage, na kuan na siya seepage through it in cubic meter per hour per meter with if h is equal to 3 meters and a is 5 degrees, or the angle of inclination is 5 degrees. Okay, so since we are calculating for the rate of seepage in cubic meter per hour, so anyong tanaw na ni is this unit, di ba? So looking at the first one, cubic meter per hour, so meaning that's discharge or the flow rate. Yeah, ano na may per meter? So of course, per meter siya because since we don't know the z-axis of the figure, so we have to kanang allocate a per meter aspect sa z-axis or sa kanang width niya. Okay, again, if we're going to use the formula, so let's say, so ito yung formula gani, itong, so kahit QL, di ba? Grabe na yung advertisement na di ba? Na, again, since we are looking for Q, diba, dili kaning big Q because the big Q is the volume. So ato lang na K equals QL. Di ba? Okay, so if you're looking at the problem, so we are given the K, di ba? K is 4.8 times 10 to the power of -3. A, the area again, if you remember earlier, the area should be perpendicular to the direction of the flow. So since mo man siyang direction sa flow, so dapat ang ato ang area is perpendicular sa kaninga direction. So meaning ana dili kaning h but kaning inclination niya dili di ba kay dapat siya perpendicular. Na dapat siya mabangga dili in the perpendicular manner. Now since we have 5 degrees, so dapat kani siya 5 degrees po na siya diya. So ano 5 degrees po na siya diya? So if you recall sa inyong trigonometry, sa inyong senior high or sa high school, if this one is 5 degrees, so this one is also 5 degrees. Diba? Sakto, di ba? So, mana siya. Okay, so if we're going to solve for the area, so kaning inyong height dire, perpendicular sa flow, is again, mo na siyang 90, di ba? Okay, mo na siya atong perpendicular. So we're going to use what function man? So to solve for this side is we're going to use cosine function. So h cosine 5 degrees. So muna siyang aside. And again, since what about sa z component, kay ang metabuan na is murag ato na siyang i-represent by per meter nga length, di ba? Or let's say 1 meter na or per meter. So muna siyang ato ang area. Okay, so let's see. So muna siya, di ba, ang area? So na natin area. Ang ato ang H is H all over L, di ba? So the total head. So atong total head is, of course, kaning H ra, di ba? Okay, we can say that muna siya ang that the surface of the water going towards the lowest point of the water, which is 3 meters. And the length, so again, the length should be parallel to the direction of the flow. So meaning ana, kani nga length ang iyang pasabot kanitanan. Ba kanitanan, di ba? So meaning ana, if this one is 5 degrees, di ba? And let's say muna siya yung total distance L. Let's say, kuha lang siguro siya X, di ba? X na. Okay, para muna siya ato ang L. Okay. So our L is sama na siya pag-solve. So we're going to use cosine gapon, di ba? Or sine. So cosine gapon, di ba? So the length is X cosine 5 degrees. So ana na siya pag solve. So again, our head loss or the total head is from the level of the water going towards the lowest part. Baka okay, kuan wala may lang basihan sa water, di ba? Dili day. Sayop akong pagsabot. So diri siya kuan dapat day. So if mo ni siya ang highest point, ang lowest point should be this particular area. So mo ni siya ato ang head difference kani siya. Delta H or the H. So again, 5 degrees na siya. So there is also 5 degrees. Okay? So since this one is X, diba? The same as the X in the lower part. So we can solve delta H by using the sine aspect or the sine function. So that's X sine 5 degrees. So plugging in all the formulas. So K. So dapat ang inyong K is in, pag inyo pa ni convert into kaning cubic meter per hour. And then ang inyong area is H cosine 5. So that's 3 cosine 5 times 1. And then H is X sine 5 degrees. So ako lang isuwat diri para makita. So ako lang so isuwat babaw lang. Okay, one space. So ako lang ibutang diri na the K, whichever is your conversion is, times A, that's 3 cosine 5 degrees times 1 meter. That's the area. So this one is the area. Times the height, the head loss. So that's X sine 5 degrees. Then Q is the unknown parameter. And then L is X cosine 5 degrees. So if you're going to divide X cosine 5 degrees sa left side, so this one is H, this one is K, this one is L, para well represented. So if we're going to divide L on the other side, so we can isolate the Q and we can eliminate the unknown constant nga X, di ba? Okay, X divided by X is 1. So muna, you can solve for Q. So ang kaning 1 meter diri is ay lang siya isagolog multiply kay again per meter man ang iyang pagkuan. Mo na siya ang pasabot diri nga per meter. Na kani diri kanay akong isirkulag maayo. Kani siya. So meaning ana inyong i-multiply is kanira kani O kani. Ang 1 meter is pabili na ng 1 meter diya para makabilin siya sa inyong final answer. Kay if inyo i-multiply ang per meter dire, mahimo na siyang meter to the power of um, 4, di ba? So, ang per meter ana is, for example, makakuha mo answer nga, let's say, makuha ang answer kay 3.2 cubic meter per hour per meter. Now, let's say, nagabot yung societies, makibaw na mo nga, ang inyong entire width sa inyong area is 5 meters. So, times 5 pa ni siya. So, meaning na 3.2 times 5 is puno dyan siya inyong exact rate of seepage for that particular area na quantity na inyong na-figure out. So, ka-G ra, ka-guess ra. So, muna siya inyong seepage rate sa kaning problem. So, seepage or discharge or kanang bisag unsa pa na siya nga way of representing the term, always look for the units nga gi-provide sa problem para dili mo mawagtang. Okay. So next slide. So muna siya, di ba? So if you look at the figure, so dire is ang gamit na parameter instead of x lang kay L prime lang. So kung ang gamit is x lang gamit ako. So if you look at, di ba? 3 cosine alpha times meter, di ba? Per meter na siyang width kay mo man siyang area. Okay, so muna siya. So na-simplify na siya diya. So walay answer lang kayo. Okay, so let's go to 5.4 and then I think after ani is mga kanang gamay na lang a topic after ani. Or we can cut ng siguro then we continue on Friday. Come on, sa may kuha ninyo. Okay, 4:30 na sad. Okay, so so Friday lang kay murag kapoy na jud na asaw kapoy sa go. Na sige ato na tiwason kadiyot kay para inig Friday lain na sad na I think inig Friday gamay lang tong i-discuss Friday. Okay, na kuha na sad ko na ugtas sa sad ko. Mga Friday, mga kuha ata mga Friday, mga 1 hour na. 1 hour max or less. Okay, so let's solve the last problem. Okay, so if we're going to solve the falling head, so again, mag-remember mo Tagalog, di ba? Tagalog Tagalog di ba? Or takalin, di ba? Takalin. Takalin. Kaya ang log sub E is ln man na siya, di ba? Natural log naman siya. So, para na yung timanan. So, looking at the given data, so what should be the area of the standpipe for the head to drop from 64 cm to 30 cm in 8 minutes? So, looking at the data, so puro cm, di ba? Puro cm, puro pod minutes. So, there's nothing to convert sa kaninga problem. Which is nindot, di ba? So 8 minutes. So area of the standpipe is katong small letter A kani, di ba? So 19 cm squared and then the K is 0.175 and then equals A, diba? Gamay nga A, then times 38. So either of the two, so log sub E or ln, so ang magawas nga answer pareha ra jud. Or if katong inyong gamitong katong 2.302 nga empirical nga value, so ang answer pareha gyapon. Mo differ ra sa mga the following decimal points. So ln, so let's say ln lang kay para mas madali. So H1 is from 64, that's the initial, going towards the final 30. So the only unknown is the A. Then you can solve for A. So anara. Easy. Kaayo. So let me clear the kwanza. So again, if you're going to use this formula, the same gyapon ang answer. Okay, so I think mo siguro na karon kay tomorrow, in Fridays, I'll be discussing this one. So dali na ni siyang mga last few kay murag actually abi nung ma-discuss na ko tanan niya, murag hapit mo time ko niya. Sure ko naugtas na mo sa diya. Kaya ako naugtas sa good result. Yeah, basin ay ay tanong ko niya trending nga kay basin nag-promote ko skuan. So let me stop the recording first. Sa